In this lesson, we're going to continue to look at some real-world applications of linear functions. This problem is a little different from what you've seen in the past because of the information that's given to you here. So let's go ahead and take a look. So first things first, I want to read and make sure I know what's going on here. The number of dollars per month it costs you to own a car is a function of the number of kilometers per month that you drive it. Based on information in an issue of Time magazine, the cost varies linearly with the distance and is $366 per month for 300 kilometers per month and $510 per month for 1,500 kilometers per month. So what is this saying here? We've got the number of dollars per month it costs you to own a car based on how many kilometers per month you drive it. So how far you drive it every month will affect how many dollars you have to pay per month. That varies linearly, which is important, which means it has a constant rate of change. It's $366 per month for 300 kilometers per month, and it's $510 per month for 150 kilometers, or 1,500 kilometers per month, excuse me. So that's all our important information. Now that we understand what's going on and we have the information pointed out, we need to write a particular equation expressing the cost, C, in terms of the distance, D. So if we're thinking graph here, we know that x is the independent variable and y is the dependent variable. So which variable depends on the other? Well, the cost is based on how far you drive every month. So that means the cost depends on the distance. So down here, I'm going to go kilometers per month. That's my x. And the price, dollars per month, is going to be my y. So independent, dependent. What I'm going to do here is set up a nice little table. Cost is going to be y, distance is going to be x. So here I'm just going to put the points. It's 300 kilometers per month, $366, and it costs $510 to go 1,500 per month. Now I have two XY points here. This is just a regular table, something that we're used to seeing and something that we can definitely write a linear expression for. So let's find the change in x is from 300 to 1,500, which is 1,200. And the change in y, which is, I'm going to use a different color so you can actually see it, 366 to 510, which is positive 144. So my change in y over change in x is 144 over 1,200, which reduces to 3/25. Now all I need to do is find the y-intercept. So of course we know that y equals mx plus b. We know the slope and we can choose an xy. Here's an xy where x is 300 and y is 366. So let's say 366 equals 3/25 times 300 plus b. We find that 366 equals 36 plus b. When we subtract 36 from both sides, we get b is 330. So my expression then would be y equals 3/25 x plus 330. Let's go into answering some questions about what that means. Predict your monthly cost if you drive 1,000 kilometers per month. Well, which one's distance and which one's cost? X is distance, y is cost. This is a distance they're giving us, so we will say y equals 3/25 times 1,000 plus 330. And we find that the cost of going 1,000 miles is $450. You do something very similar, which is just plug in the 2,000 if you're trying to find that. How far could you drive without exceeding a monthly cost of $600? So is that a distance or a cost that they give us? It's a cost, so that's why we know that 600 has to be 3/25 of the amount of miles we drive per month plus 330. You can subtract 330 from both sides and get 270 equals 3/25. You can either multiply by 25/3 or divide by 3/25. It's the same thing. That will let you know that you can drive 2250 miles per month. Miles for every month if you want a cost of $600. So anything 2250 or less than that, you're good to go. Find the cost rate intercept. That means which one? Cost is y. So this wants you to find the y-intercept. Well, we know that from the equation. That's 330. What does it tell you about the real world? Well, that means when x is 0, y is 330. So what is x? Distance. When the distance is 0, then the cost is $330 per month. So what this is saying is if you have the car, even if you don't drive it at all, it's still going to cost you $330 a month. That's what's going on here. We're talking about distance and how that affects the cost. If you have the car but don't drive at all, it's still going to cost you $330 a month. This says calculate the distance intercept. Well, which one's distance? That's x. What's the x-intercept? Well, that's where y is 0. So, when y equals 0, then, and from here, you can subtract 330, divide by 3/25, get that x is negative 2750 miles per month. What does this mean in the real world? There isn't a whole lot of sense to this number. Let's think. This means when y is 0, so the cost is 0, your distance would be negative 2,750 miles per month. I can't drive a negative distance every month, especially such a large negative distance. That makes no sense. So the cost will never be 0. Essentially, this doesn't make sense for me to have the car and pay nothing because I drove negative miles. This is a nonsensical situation here. Okay, last couple parts. It says plot the graph of this linear function. Use a suitable domain and label the horizontal and vertical axis. So we're going to do that. Let's set it up. We have to remember which one's independent and which one's dependent. The independent is the distance you drive. So kilometers per month down here. The dependent depends on how far you drive is the dollars per month that you pay. We know that the slope is 3/25 and that the y-intercept is 330. So we have to make a legitimate scale for this. So this is the origin. It's the point 0, 0, where x is 0 here, y is 0 here. We don't have a lot of space to get all the way up to 330. So what I'm going to do, what you can do, is draw one of these. That means I have cut off a portion of this axis here, where it's not going to be to scale from 0 to this first point, but it'll be to scale everywhere else. This just means I cut out a little part of it. That's what this symbol means. So since 330 is our starting value, let's go ahead and start there. Let's look at what our slope means. This is change in y over change in x, which means so as x changes 25, y will change 3. So let's just go ahead and make it easy on ourselves and make that our scale. 3, 3, 3. So my jumps are going by 3. Down here, x is changing by 25, so we'll go from 0 to 25 to 50, 75, 100. Now let's graph. We know the y-intercept is 330, and then we know the slope is this because we made our scale just like that. Nice and easy for us. And then we can graph it. Y-intercept with the correct slope, and here we go. What is the slope and what does that number represent? Well, this is the slope, and it's for every 25 miles you drive per month, every 25 miles more you drive per month, you will pay $3 more per month. So a quick recap. We made sense of what was going on. We found the important information. We set up a little table. We decided which one was the independent and dependent variable. X is always your independent. Y is always your dependent. We use this table to come up with the linear equation. We use this linear equation to find some values. We made some sense of the x and y intercept. We were then able to set up a graph, making sure that we have the independent variable on the x-axis and the dependent on the y-axis. We chose a scale based on the movement here, and we cut out this part of the graph because it was going to be too big of a jump here and we couldn't scale it all the way up to 330. So we gave this little symbol. And then we made sense of what the slope means. For every 25 miles per month you drive more, you will also pay $3 more per month.